Welcome back, Algebra 2, to Part 2 of Section 6.4. We're going to be looking at coterminal angles. So to start this off, I'm going to draw 120 degrees in standard position. Vertex at the origin, initial side on the positive x-axis. Here, theta is a positive angle, so we want to make sure we go 120 degrees counterclockwise, which will look something like this. I'm going to draw another angle that's coterminal to theta, negative 240 degrees. Standard position as usual. And because this angle is negative, we're going to move 240 degrees clockwise. So this is 180. Then I need to go 60 degrees more. And it'll look something like this. This will be alpha. Then we draw you one more angle that's also coterminal to the previous two angles. I'm going to let beta to be 480 degrees. Let's look at what happens when we draw this angle here in standard position. Once again, this angle is positive, so I'm going to go 480 degrees counterclockwise. So 1 full revolution is 360 degrees. I need to go 120 degrees more, which will leave me in quadrant 2, and it'll look something like this. So look at all three angles. Think about what makes them all coterminal angles. If you noticed, they all share the same terminal side. Right? If I drew all three angles on the same coordinate plane, their terminal sides would all coincide. And that's what it means for angles to be coterminal. They share the same terminal side. So in this example here, we can say that theta and alpha are coterminal angles because they have the same terminal side. And so one of the things you should notice is if you look at all three angles, right, look at their values, 120, negative 240, 480. If you notice, I can take theta and simply subtract it by 360 degrees, and then that'll give me alpha. I could have also taken theta and added 360 degrees, and that'll give me beta. If you notice, if we add or subtract 360 degrees, you're just making one complete revolution, and so the angle that you get would have the same terminal side as the angle you started with, right? And that's what we're going to be doing when we want to find the coterminal angle to a given angle. So if theta is any angle, then depending on whether you're in degrees or radians, you're pretty much going to do the same thing. If you're dealing with degrees, what you're going to do is you're going to take theta and you're going to add or subtract as many multiples of 360 degrees as you want. Or if your angle is in radians, you're going to add or subtract as many multiples of 2 pi k as you want. In both of these cases, k is just an integer. And so in the end, if you add or subtract 360 degrees k or 2 pi k, you're going to end up with an angle that is coterminal with theta. And again, note k is any integer. So now the question is, why do we care about coterminal angles, right? Well, there's something special that happens with them. So if you remember in the previous video lesson, we were dealing with trig functions of angles that weren't acute. Let me draw an angle in quadrant 2. Let's draw 150 degrees, let's say. And what we did was we took an arbitrary point on the terminal side. Let me take this point here. Let me just call it x comma y. We define r to be this distance right here, right? If you remember, this was the formula we used to define r. And so if I want to find sine of 150 degrees, I'd use the ratio y over r. Now, instead of using 150 degrees, what if I took an angle that was coterminal to 150? Right, let's say I did 150 degrees minus 360 degrees. That'll give me negative 210 degrees. Let's draw that in standard position. negative 210 would mean I go clockwise 210 degrees. You notice they have the same terminal side. So then if I said, hey, what is sine of negative 210 degrees? Do you agree that I'd still get the same ratio, right? Y over R. Because the point didn't change, R didn't change. The only thing that changed was the angle itself. So if you notice both angles, 150 degrees and negative 210 degrees, they both share the same terminal side. So naturally, sine of 150 degrees would be the same as sine of negative 210 degrees, right? So these two angles that are coterminal will have the same trig values. And that's what's the big idea, right? Because coterminal angles have the same terminal side, we can say that the values of the 6 trig functions of coterminal angles are equal. And we're going to be using this idea quite a bit when we're trying to find the trig function of an angle that's really big or really small. Let's look at our first example. Here we're going to find the exact value of cosine of 420 degrees. And so what I'm going to do here is just draw a quick visual. 420 degrees. Well, first off, it's a positive angle, so I know I need to go counterclockwise. This is a full 360 degrees. I need to go 60 degrees more, which will leave me somewhere around here. Now, that angle is a big angle, but if I find an angle coterminal to that, I can do that by just subtracting by 360 degrees. And if I do, I get 60 degrees. And so these two angles here are coterminal. If I were to draw 60 degrees here in standard position, you see how they would both share the same terminal side? So we know then that if I want to find cosine of 420 degrees, that's just going to equal cosine of 60 degrees. Now we're just finding cosine of an acute angle, which is what we talked about earlier in this chapter. So hopefully by now you memorize what cosine of 60 degrees is. This is just 1/2. If you forget what cosine of 60 degrees is, you can always draw a right triangle. Shortest side is 1, hypotenuse is double the shortest side. The longer leg is square root of 3 times the shortest leg. And then from there, if I want to find cosine of 60, I'm going to use my SOHCAHTOA acronym. Here, cosine would be adjacent over hypotenuse, and you get the same answer. But hopefully you have these memorized because you're going to see these values so often. If you don't know them now, I say go back and memorize them as soon as you can. Number 2, sine of negative 7 pi over 4. So once again, here we're dealing with a very small angle. And so to make it more manageable, what I'm going to do this time is add 2 pi. Now, in this case, I want to make sure to have common denominators. 2 pi is really just 8 pi over 4. And when I add these up, I do get pi over 4. And so what this tells me is that sine of negative 7 pi over 4 is really the same thing as sine of pi over 4. Once again, this is one of your acute angles. Sine of pi over 4 is root 2 over 2. Hopefully you have that memorized. But if you didn't, you can always draw a 45, 45, 90 triangle. Because it's isosceles, I'm going to call these sides both 1. The hypotenuse would be rad 2. And if I were to find sine of this angle here, I would use opposite of hypotenuse, which would give me 1 over rad 2. And if you rationalize it, you get the same answer as we got the first time. So hopefully you can kind of see how these coterminal angles can be used to evaluate trig functions of angles that are usually really big or really small. By simply adding or subtracting as many 360s or 2 pi's as you like, you make the angle a little bit more manageable. So at this time, I want you to try number 3 on your own. Pause the video, and when you're ready, press play. So here I have negative 540 degrees. I'm going to add 360 degrees to this. I get negative 180 degrees. Some people don't like negative angles. So if you want, you can add 360 degrees one more time, and you'll get positive 180 degrees. So just so we're clear, negative 540, negative 180, and 180 degrees, these 3 angles here are all coterminal angles. Right? They're all coterminal to each other. So secant of negative 540 then would be the same thing as secant of negative 180 degrees, which is the same thing as secant of 180 degrees. Right? This would just be negative 1. The way you can derive this, by the way, is you can just draw your angle here in standard position. 180 degrees will look something like this, right? And then you could take an arbitrary point on the terminal side. I'm going to pick negative 1, 0. I know that if this distance here is r is just 1. And then if you remember, cosine of 180 degrees is x over r, which in this case is just negative 1 over 1 or negative 1. Secant of 180 degrees is r over x, or you can just take the reciprocal of what we just got, right? And it's still negative 1. Just make sure you know how we define these trig functions when we extended the angles outside of the first quadrant, okay? If you got that right, nicely done. If you made any mistakes, make sure you review it, make sure you understand it, and then when you're ready, try number 4 on your own. So for number 4 here, the first thing I'm going to do is make this angle a little bit smaller by subtracting by 2 pi. Once again, you want to make sure you have common denominators here. And if you simplify this carefully, you do get pi over 3. So what this tells me then is if I want to find cosecant of 7 pi over 3, I can just find cosecant of pi over 3 instead. Now, if you remember what cosecant of pi over 3 is, that is just 2 rad 3 over 3. And if you don't have this memorized, you can always just draw a 30-60-90 triangle. Label the sides. And if you want to find cosecant of pi over 3, well, pi over 3 is the same thing as 60 degrees, right? Cosecant, if it helps, you can think of it as 1 over sine of pi over 3. And sine of pi over 3 is just opposite hypotenuse, which is rad 3 over 2. And then 1 over that would just be 2 over rad 3. If you rationalize this, you do end up with the same answer we got the first time. So really at the end of the day, if you know sine, cosine, and tangent of all the acute angles, or all the quadrantal angles, you can find cosecant, secant, and cotangent pretty quickly, right? Ultimately, just understand what coterminal angles are, how to find coterminal angles to a given angle, and how you can use them to find trig values of angles that are really big or really small.